It's one small step for man, one giant leap for mankind.
And welcome to a very special edition of the Syzygy podcast. This time we're talking about something which is a bit topical right now. It's 50 years since a very big thing happened. Sitting opposite me at the microphone, as ever, Emily Brunsden. What happened 50 years ago?
Well, we landed on the moon.
I wasn't there.
No, neither was I.
But we collectively, as a species, landed and set foot on the moon for the first time 50 years ago. I'm guessing you've probably heard of that by now. It's all over the news. NASA and every other space program on the planet is getting very, very excited about this anniversary. And it is a big deal because this was, I don't know, it's hard to put your finger on a more significant moment in science and technology in history that changed our view of ourselves in the cosmos. Can you think of anything?
Very few. I think, this is definitely up there. And this is definitely up there because it was a huge coming together of people and science and technology to make endeavors, not just because we can, but because we're curious and we think it's important. So I think a lot of what we're going to be talking about today is kind of that human impact of what this all was all about.
Yeah, there's going to be plenty of podcasts and documentaries and TV specials and, probably Muppets episodes and all sorts of things about landing on the moon around the moment. But the tack that we thought we'd take on it is, okay, so from a sort of scientific, astronomical, from our typical Syzygy angle, what's the importance of the moon landing? So that's where we're going to go today. The only other thing that I can think of that's sort of even vaguely on the same scale is sort of the Human Genome Project, again, of modern times. But this thing which took so long and so many people and is now almost trivial. It took years to sequence the first human genome. What is it? Coming up to 2 decades ago that started. It took years and it took billions. And it's now something which you can pretty much order away for overnight. It's now become not quite trivial, but almost. Similarly, landing on the moon's not trivial, but now we're at a point where loads of different organizations, both government and private, are gearing up to go back to the moon. Whereas the first time we did it, it was really hard. This was something that was right at the edge of, I don't know whether we can do this or not. So should we kind of start there with what happened? How did we as a population, as a society, as a species, how did we land on the moon?
There's so many fascinating stories as part of our moon landing history, and there's absolutely no way that we can talk about all of them. Everything from the very initial Kennedy speech, which is we're going to be there in a decade.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
To the beavering away that hundreds and thousands of people did across America, across the globe to make it happen. The tensions that arose because of the space race, the international politics. It's just
hugely political, but something that led to, as you say, such an amazing collaboration across so many groups. Not entirely international at that point. That kind of came a bit later because it was very political and it was us versus them. We've got to get there. I do wonder whether during Kennedy's famous speech, we choose to go to the moon, there would have been a lot of people going, yeah, and there would have been a lot of people going, really? How are we going to do that? The people actually involved must have been a strange mixture of real excitement and, oh God, how are we going to pull this off? But what an amazing decade it was after that.
Amazing, yeah. And so if we were to really put this in context of the time and the place that it sat in history, I suspect we'd be sitting here talking for 10, 15, 20 hours. But if we sort of put that aside and maybe just we review very much the quick facts, if you like, of what happened during the actual event, then we can maybe think about those impacts that have happened over the last 50 years, and I think take a step back and appreciate what it has done and what has changed in our lives today.
Yeah, I think that's a good idea. I just want to throw in a stat that I heard the other day, though, which I'd never thought about before. But when Kennedy got up to make his speech, I have heard, and if anyone out there who is an utter space nut cares to contradict this, fine, write in. We'd love to hear from you. But I've heard that when Kennedy made his speech, Americans had a total of 16 minutes of space experience at that point. You know, they had 2 missions, I think, at that point, which had sent something up into space for 8 minutes, and back down it came. And 2 of them. Total of 16 minutes in
and
space.
Not people.
Yeah, not people.
Nothing living.
Not people, no, just stuff. But based on 16 minutes in space, 16 successful minutes in space, yeah, let's go and land on the moon. Let's put a human being on the moon. That takes, that's chutzpah right there. Anyway, so let's get back to that. Landing on the moon. What happened?
Right, so we have 3 astronauts who must be 3 of the bravest human beings, I think, that we've ever encountered on our planet, because it's so easy to forget just how dangerous and uncertain and nervous these people must have been.
Yeah. I mean, before that, this was Apollo 11, and so there were 10 Apollo missions before that, all of which were gearing up to this point, getting stuff actually into space at all with these rockets, and then getting towards the moon, going around the moon and coming back home again, having something land down on them. Was there a lander, but an unmanned lander first? I find it hard to believe that they would have sent humans down without testing the lander. But maybe, I don't know. But everything leading up to that point. But they were the first ones to actually go, yep, we are going to come down and land and then open the door and get out. And that's terrifying. I mean, it must have been just, that first moment must have been just freaky.
Yeah,
utterly freaky.
It's incredible. And I think it's telling. And so these 3 people, Neil Armstrong, Buzz Aldrin, and Michael Collins.
Michael Collins is the one that you never hear about, because he was the one left circling the moon in orbit, waiting to pick them back up again. He was the one in the getaway car.
Yeah, definitely.
Yeah.
So these 3, it's kind of telling in some ways that they never flew again as astronauts after this mission. Because, I mean, how could you top such an incredible experience to be the first people to go to the moon and land? It's really amazing. So quick timeline of what happened. So 16th of July, 1969, the Apollo 11 rocket was launched. So it contained 3 different components. You had a command module, which is where the astronauts kind of sat. You had the supply module, which had the kind of stuff that they needed, and the fuel rockets were kind of on the back of that. And, of course, the lunar module. So this is the bit that actually went down and landed on the surface of the moon. So they all went up on the 16th. The 20th, they landed on the surface. So it takes a few days to get to the moon. They landed at 2017. Now, this is universal time, so it's kind of pretty much the same thing as what you might know as Greenwich Mean Time, so coordinated time. 8 o'clock in the evening, basically, landed. And they were supposed to have a rest, to have a sleep. But I think everyone...
I don't imagine there was a lot of sleep going on.
Way too buzzed. I mean, they had not too difficult, a few little hiccups during the landing. Nothing that they had to manually land the lunar module in the end. But yeah, it was fine. But I guess the adrenaline must just have been through the roof by this point.
The entire way, just off the charts. I mean, I think there's a documentary of amazingly restored footage of Apollo 11, which is going to be doing the rounds, which I don't think it's come out yet, so I'm looking forward to seeing that. But a really nice bit of insight into what it's like inside the Apollo capsules as it's going is actually from Apollo 13, which, yes, okay, dramatized and Hollywood style. But I don't know about you, I thought that film gave a really good sense of what it's like to be in this claustrophobic environment, particularly when things go wrong, which they do in the Apollo 13 mission. And when you think about what they actually had to do, like, okay, we fire a rocket and it sends something to the moon and then it brings it back. But they've got to get an enormous rocket into space, and then they have to separate part of that rocket away, turn it around, come back, plug into the bit that's going to land on the moon, and then separate that off, and then blast another rocket and head off towards the moon. And then that bit's got to separate again and go down and land on the moon. And then it's got to blast another rocket and take off from the moon and come up and meet up with the bit that's been orbiting around with Michael Collins in it. And then that's got to fire another rocket to head it back to Earth and separate and then land down on Earth again. Like, that's an enormous amount of stuff that's got to go right.
Amazing complexity, yeah.
And if you get it a bit wrong, you're going in the wrong direction forever. You know, it's just amazing.
I mean, in an era where you didn't have computational power, right?
No.
These many, if not most of these sums were done by hand.
Yeah. Yeah. You see again in that film or in the documentaries, you see these astronauts just scribbling away on pencil on paper or pen on paper, and you think, did they really figure out entry angles like that? Yeah, they did. Absolutely amazing.
Yeah, brilliant. So, of course, they couldn't sleep. So
No.
they decided, well, we might as well just crack on and get out there on the moon. And the consequences of this were interesting because it ended up being that when they did the first moonwalk, it was actually kind of middle of the day for New Zealand, Australia, and sort of that part of the world, which is kind of a little bit different to what you might have expected. You thought maybe they would have waited for the live coverage. I'm not sure what time it must have been in the US, but it must have been sort of a little bit out of hours.
Probably not prime time.
Yeah.
No.
Yeah,
No.
so-
Well, maybe that was the reason why they sort of factored in the sleep. It's like, hang on, guys, you've got to wait for the right hour so that we can, get you on at the 6 o'clock watershed. So, but there's we're going to get out there, and the Kiwis and the Aussies can get the full look at this one.
So the timing change meant that they sort of had to rejig how they were working with the moon landing footage as well. And there's a beautiful movie about this. I don't know if you've seen it. It has a very nice New Zealand actor starring in it.
Yeah, you're talking about The Dish.
I'm talking about The Dish.
Yes, with Sam Neill, the wonderful Sam Neill.
And they take a bit of artistic license with the whole film, but it's prepositioned around these scientists who are normally working this radio telescope, and kind of the bizarre things that happen to them when the space age kind of descends in rural Australia.
Yeah, this is the big Dish radio telescope at Parkes in sort of outback New South Wales, which is a wonderful place, and this big, classic style curved dish. At one point, you see them playing cricket on the surface of the dish. They've sort of leveled it out and they're playing cricket on it. But it's a lovely, lovely film, and yes, they do take a little bit of artistic license with it. I remember going to a screening of it where the director was there, and it was at a science and science fiction conference. And they had this screening. And so the audience was filled with absolute space nuts. And at the end of the film, when the director got up to answer questions, after the first 3 questions, which were about historical inaccuracies in the film, he just turned around and said, look, it's fiction, right? We based it on real events, but we're telling a story here. So we know we got some of the facts wrong. Are there any questions that don't involve historical inaccuracies? And every hand in the room just went down. It's like, right, I think we're done here. Thanks very much. But yeah, lovely film. If you haven't seen it, The Dish, definitely worth checking out.
And it definitely conveys the sentiment, I think, of the time and the impact that this event had globally.
Yeah.
Just crazy. So this so the moonwalk itself started at 2:56 UT, so nearly 3 o'clock in the morning would have been for the UK, and this was when Neil Armstrong kind of opened up the capsule, steps down the ladder, makes his way outside, and Buzz Aldrin follows him about 20 minutes later, and just fascinating. I mean, the footage is standalone. You don't need us to commentate over it and tell you how
there's nothing we can say.
Moving it is.
Yeah. If you haven't seen it, go and seek it out.
But I think actually, if we come to sort of the timeline idea, well, you know what Neil Armstrong did? 7 minutes into his embarkment onto the surface of the moon.
I don't know, took a leak? What?
This is quite telling. Yeah. No? He collected the very first sample of moon rocks.
That's much better than my answer.
Yeah. 7 minutes it took.
Wow.
And the reason why is because it was so important to get a scientific return from this mission that he picked up a sample, put it in a little pouch, put it in the side of his spacesuit, because if everything goes wrong and they have to evacuate, get out of there quick.
Yeah, we got to go now.
Yeah. At least he's got one sample that they can return.
Which makes sense. And I think it's something that perhaps a lot of people don't appreciate is yes, exploration. Yes, let's go and set human beings on the moon. And if you look at something like the International Space Station and, you know, a lot of modern space exploration and space flight, it's all got a scientific basis to it. I mean, the astronauts on the International Space Station spend a large proportion of their time doing experiments. That's what they do. They're not sitting there at the steering wheel of the ISS going, which way should we go? That's all taken care of. They have to do maintenance. They have to get out and fix things. But when they're not doing that, they're not sitting around playing cards. They're doing science, which is awesome. And the same thing happened on the moon. Well, let's start taking some samples. Let's do some things because we may have to get out of here any minute now.
Yeah. So it just tells you the importance that the scientific, discovery had as part of this whole mission as well.
Yeah. And they're collecting samples from the moon because, as we've discussed on this podcast, like that has a lot that it can tell us. And
Huge
for the first
amounts.
time, we're able to actually bring it home.
Huge amounts, yeah. And they actually, so the whole moonwalk lasted 2.25 hours. And in that time, the two astronauts managed to collect 21.5 kilograms of moon sample.
That's quite a lot.
That's a lot. And, different types. They got some of the dust, they got some of the small rocks. They moved around and there's lovely maps you can see of all the different sample collection points. They were very meticulous in mapping, where exactly every single sample came from.
And that again shows you how importantly this was taken, how important that part of the mission was. Because if you think about how everything else must have been optimized, like we can't take up more than we can carry, and every kilogram takes that much more fuel to get off the ground in order to get into space. So everything else is being really, really tightly constrained. There's no extraneous stuff here. But we need to be able to bring back not just small vials with powder in them. We need to bring back like 20 plus kilos of moon stuff. So we got to make the space for that. That's a high priority part of this mission.
Definitely. Yeah, so it was a lovely mission. I mean, they achieved all their goals. They set up a lot of scientific instruments as well, that some of which are still in use today, like the laser rangefinders that we use to bounce light back and forth.
Yeah, they're basically
the
mirrors sitting on the surface, aren't they?
Yeah,
and you can fire a laser at the moon, and it'll bounce off one of these things. Because by the time the laser beam gets to the moon, it's very large.
Yes,
It might start off as very small, but it's very large by the time it gets over that distance. And so a bit of that hits a mirror on the moon, which then bounces back to us. And you can measure that distance really, really accurately.
So we can measure that very, very precisely, the distance between Earth and the moon. But yeah, so they went back, they had a bit of a snooze on the moon, first nap on the moon.
Yeah, which I think it makes sense to do that after you've been out for the walk.
Yeah.
I mean, if I go out for a walk, I need a snooze, and I'm not walking on the moon. I'm not surprised is what I'm saying.
And after 21 and a half hours of being on the surface, they lifted off again and rejoined the command module. 24th of July was when we had the successful re-entry and return to Earth.
What do you think Michael Collins was doing for 21 hours?
Oh, he had a lot of tasks to be going on with. They had other instruments on the command module that were making other measurements he had to look after. He had to make sure that the rendezvous was all set up.
So he wasn't just twiddling his thumbs, going, I wish I was down there.
No, and it's very interesting. You see some interviews with Michael Collins. He's not,
No,
doesn't hold a grudge about it.
I'm being
right?
facetious, and actually, I can imagine that kind of comment must really it wouldn't get under someone's skin because they're used to it over such a period of time. I guess the point is, people doing these missions are so utterly prepared for their role in that mission. Maybe there is some underlying, it would have been nice to walk on the moon, but I am absolutely key to this, and I'm not even going to question my role.
Wow, I mean, just to be even a tiny part of that mission must have felt amazing. Just amazing. Yeah, so and we had the whole Apollo program. As you said, Apollo 11 was just one in a sequence of those. In total, we went to the moon 6 times for manned missions. 10 people walked on the surface of the moon between 69 and 72.
Because it went up to Apollo 17 was the last one. So that's 11, 12, 13, 14, 15, 16, 17, which should have been 7, but 13 didn't get on the moon.
No.
They got to the moon, they went around the moon, and then they came back as quickly as they possibly could because it all went horribly wrong. See the film.
Yeah, so in those missions, we brought back 382 kilograms in total.
That's a lot of moon.
That's a lot of moon. Yeah.
They'd still be working through that.
Oh, yeah. So that's broken down into 2,200-ish samples. And I saw a stat there that about 400 of those NASA loan out every year for teaching or research purposes. I mean, as a researcher, you can still request Apollo moon rocks to do some of your research on, because
That's so cool.
that's still pretty much all we have is pure moon samples. Right?
Yeah, well, we haven't been back since, have we? We must have been
We
back.
haven't had sample return
No.
since
That,
then.
I'm sorry, that's what I meant. We haven't sort of gone and collected stuff since. I was just trying to think, have there been landers on the moon since then? I can't remember.
The most famous, well, there's been, the Chinese one that landed just about a year ago.
Yeah,
just
very
just under a
recently.
year ago,
But Apollo 17 was what, early 70s?
yeah, definitely.
And so that's a long time. That's, 40 plus years, 45, almost 50 years since we left the moon for the last time and haven't been back.
So a lot of people ask, why haven't we been back?
That's a really good question. Why not?
I think there's a few answers to that question. I think the first one is, it's freaking dangerous.
Yeah, it's expensive. It's dangerous. Did we mention it's dangerous and really hard to do? It's a long way away.
It would have very bare minimum technology to even be able to do it. I mean, the fact we did it with the technology we had is just, you as a historian, and 200 years in the future, you'd look back and you just say, you just made that up, surely.
Yes.
You couldn't have gone to the moon with that stuff.
You could have waited a couple of years and basically done it all with your iPhone, couldn't you? Like, the computing power that were on these things alone, you're nuts to even try this. It's like trying to go in a boat. It's just ridiculous.
Yeah.
But they did.
They did.
Because that was the goal.
Yeah, we had a different sort of cultural sentiment about explorers and how much a human life is worth risking. And in the 60s and 70s, that was kind of okay. That was an okay level of risk. And I doubt that level of risk would ever be repeated today.
No, it's an interesting question, isn't it? It'll be really interesting to see what happens with this next generation of space flight, trips to the moon. Lots of people are doing it, from NASA and the European Space Agency through to the private companies of Blue Origin and Virgin and SpaceX, Elon Musk's pet project. It'll be really interesting to see how that's managed. But also, the fact that we haven't been back to the moon as humans, we haven't set foot back on the moon again in many decades. But we've sent a lot of stuff to Mars. We've sent space missions to Mars. We put little buggies down on Mars, driving them around and so on. But we haven't done that to the moon. It's almost like, from an exploration point of view, we went, okay, well, we've done that. We'll leave that now. Let's set our sights further. Not in sending humans, not yet. That's a much harder problem. But let's send stuff to Mars and let's do that. Let's tick that one off. And that seemed to take over.
Yeah, well, definitely. We focused on other scientific projects, basically. So for solar system exploration, definitely Mars became the big thing. But also in terms of human space flight, the International Space Station took over. So preparing, developing, building that. And to this day, astronauts are up there all the time performing, as you say, experiments. And they go up there for significant periods of time. And you think the moon and a landing in 1969 was 8 days of astronaut space flight time. No one had really any clue what 8 days would do long term to a human. Now we send up people for months and months, and we have very good data from the International Space Station of what long haul space flight would do to a human body.
So even though the space station is, it's pretty close to the Earth. It's not very far away. It's just up there. You could almost touch it. In comparison to how far away the moon is, there's an enormous amount of really important stuff that we've got to figure out, as you say, about the long-term impact of just being in space. But also, how do we do long-term space missions? What do you do about when things go wrong? If something's going to the moon and back, that's a very different prospect to, but we've got to have this spacecraft in orbit for years and years. And if stuff goes wrong, what do we do? And if you think about that longer term, eventually, if we've got, missions that end up setting up a space station around the moon, or even, something on the moon that can be a permanently manned base. And then further, if you're going to Mars, at the moment we can send something up to the ISS to replenish its supplies, and if something's broken, we can send up a new one. We can't do that nearly as easily if something's around the moon or on the moon. And we certainly won't be able to do it if something's on its way to Mars. So we've got to figure out now, how do you make sure that stuff on the International Space Station can be run independent of us down on the ground for longer and longer periods of time without sending up, a rescue plan?
Yeah.
And that's really hard stuff. That's much harder than anything we've done before.
Definitely. And I think that's why we're now returning back to the moon. So we did our Apollo missions. We got the fantastic scientific samples that we were, 400 kilos of stuff, what seemed to be kind of pretty a good amount. That was enough to do the research we needed for the time. And we didn't have a very compelling argument to send people back there. Now we're entering an era where spaceflight is developing to this next generation of stuff, right? And we're thinking about, well, should we be setting up moon bases, stepping stones to getting out there into the solar system to do this more extensive space travel? And that's why now it's coming back to the forefront of, well, if we can develop the technology to sort out putting people on the moon, building structures on the moon, then maybe that can sort of spur us on and will perhaps be a jumping off point, if you like, for getting into deeper space. Yeah.
And it is interesting that it's all happening now. And it really does make me wonder about the convergence of modern technology. Computing power has become so ludicrously easy. We carry around in our pockets these amazing computers. Wear them on our wrists now, for goodness sake. Things which are far, far more powerful than what got us to the moon in the first place. But that's really only kicked in the last decade at most. And it's over the last decade that these more ambitious space plans have started to become developed. And it's the merging of those technologies of, well, okay, maybe we're ready. We've been doing lots of stuff on the International Space Station. That means that we're getting more confident about doing those kinds of longer term missions. And now the technology, we can build stuff, we can program stuff, we can do this. Let's do that next phase of humans in space and expanding our horizons. It's pretty exciting.
It's very, very cool.
So from a scientific point of view then, going back to the moon, what do we think? Is that going to be more about trying to build up the capacity to get further out into the cosmos?
Part of it. I think there's more things we can learn about the moon as well. I mean, if we come back to the original question of kind of the so what was the outcome of landing on the moon? Of course, huge cultural impacts, and we'll talk a bit about some of the scientific cultural impacts that had. But I also found, if you go back and sort of review the Apollo program, the Smithsonian Museum actually did a really, really nice kind of top 10 things that we learned from this program, top 10 scientific results. So we can, if we start from there, then we can kind of build up, well, where do we go from there?
Okay.
So if we go, should we have a top 10 countdown?
Let's do it. Yep.
All right.
Coming in at number 10.
Coming in at number 10. Well, I've got them.
Are these in order?
Well, I've got them 1 to 10.
Oh, okay.
Can we do a number 1 first?
All right. But are they in order? Are they in order of?
No, they're in no particular order.
Okay, so in no particular order
10 amazing things that we learned scientifically about from the moon, from the Apollo missions.
All right. Starting at number 1 then.
First one, the moon is not primordial.
Right.
So what that means is that it's not just a little lump of rock that was kicking around at the very, very beginning of the formation of our solar system, and that the Earth sort of captured along the way, and then we merrily continued to evolve together.
See past episode of Syzygy, Crazy Donut Moon Theory.
Yeah, episode number 37. So we're going to refer back to that one a lot because a lot of these relate to the data that eventually led to that theory.
Yeah.
Right? So,
and that's a big finding.
It's
because,
big. It's really
something
big.
as prominent in the night sky as the moon, you will assume, as we have for the vast majority of our civilization, that it has been there forever and will be forever and is unchanging and is anything from a god to the same stuff as us. And so finding out the origin story of the moon is a big deal.
Definitely, definitely. So it's not primordial. It was a really big discovery.
Yep.
Second of all, the moon is really ancient. And it contains a history of the solar system that we don't necessarily get from the other terrestrial planets.
Interesting idea that you can only really learn about the past history of the solar system. You can't learn about that directly. It's only indirectly. It's only by gathering samples and circumstantial evidence to put together and go, it all adds up. It must have been this way. You can't watch it.
Yeah, yeah. And so we could go and look at geological records on particularly Venus, Earth and Mars, but we have other weathering processes, we've got volcanism, we've got all these things which are continually changing the surface of these planets. That mean that things like cratering history, which tells you about periods where there might have been lots of impacts, for example, they're just gone from our surface. And so having the moon there, which has kind of been very static and stable in its surface history over time.
The moon's
really,
covered
really
in
useful.
craters, particularly when you see pictures of the far side of the moon, where... Am I right in thinking that like when you do see pictures of the far side of the moon, it's incredibly more pockmarked with craters than the side that we can see, which has got lots of craters on it? Is that because the Earth's basically shadowing it? In a way?
We're not entirely sure all the reasons why that is. Partially, because things have been flying in and hitting it. But there's also quite a lot of complex geology of the moon that we don't really understand, the difference between the near side and the far side. The oceans, for example, the Mare, are not present on the far side of the moon. So,
So, interesting stuff there.
Yeah, lots of stuff.
Okay, so that's number 2. Is that number 2? Number 3.
Number 3, interestingly, this is also a leading in factor for our... where the moon came from. The youngest moon rocks are about the same age as the oldest Earth rocks.
Youngest moon rocks, about the same age as the oldest Earth rocks, which means... Hang on, I haven't had enough coffee to put that one together.
So it means that, the Earth has continued to evolve and generate rocks, basically, through geological processes, whereas there was this point in time where moon rocks and Earth rocks were the same age, and the moon didn't get any new rocks after that. It stopped. I mean, aside from things which have bashed into it, the point is that the Earth is continually, bringing up new material from inside through, volcanism and plates coming together and subduction or whatever those are called. And it's constantly making new stuff. The surface is changing and growing and bringing up new stuff from within. But the moon's not doing that. Yeah, the moon's really old. Really old. So after just saying that the moon's not primordial, but it's still quite old. So number 4, its moon's made out of the same stuff as the Earth.
Yes.
Not at all obvious that it should have been, right? There's no reason really why we thought it was. Most of scientific history, we presumed that the moon was captured from somewhere else. In the solar system.
I mean, if you allow for the possibility that the moon and the Earth haven't been around forever and were created at the same time, if they were created at all, then all sorts of theories. And where did it come from? So the fact that they are made of the same stuff is really important. See Crazy Moon Theory, episode 37. Yep.
Number 5, again, not obvious, but, it feels like obvious to us now, but it wasn't at the time. The moon is lifeless.
Yes. Yeah, it was always possible that... I mean, we could look at the moon. It's obviously not covered in trees and dolphins and things, but it's possible that there could have been stuff down in the soil. Yeah,
microbes, bacteria, whatever.
And nothing.
No, nothing.
Which is interesting. Slightly disappointing, but interesting.
Yeah, it does. It even is deficient in organic material. So there's kind of very little chance that anything could develop on the moon.
So it kind of underlines that one, really, doesn't it? Yeah. Okay, let's look elsewhere.
All right, number 6. The moon rocks have been under processes of very, very high temperature. So that means they've kind of melted at some point in the past. And that's pretty much their only formation mechanism, melted stuff. On Earth, you have rocks that are formed from, say, water processes, like sedimentary rocks, where you just sort of use water to put layers and layers of particulate matter together. Yeah, and then squash it down underneath very heavy oceans, and eventually, over time, you get these sedimentary rocks. But that doesn't happen on the moon. No sedimentary rocks on the moon. Because there's no oceans. Yeah, no water, and no historic water, therefore. Right, number 7, kind of related, used to have a magma ocean. A magma ocean. So it didn't have water oceans, but it had a magma ocean. So it was very, very hot and molten in the past. Number 8 is kind of an extension of this as well, where the mare, these are the black spots, the dark oceans you can see on the surface of the moon. These are giant impact craters that were once filled with lava. Oh, okay. So the when you look at a full moon on a nice clear night, you can see
the face in the moon and those huge structures, the darker parts, you're saying, and those are colloquially known as oceans or seas?
Yeah, seas. Yeah, so
seas.
They have names like the Sea of Tranquility.
Yeah, right. Yeah. And you're saying that those were massive impact sites.
Yeah.
From what?
From huge meteor impacts. So they basically dug up very, very deep material made of huge molten lake, in some cases maybe several large fractions of the surface of the moon. And then they solidified and cooled and became this sort of smooth-ish oceans.
And is this sort of back in the early stages of formation when we've talked about in episode 37 that the inner solar system was a much more violent and scary place, or are we talking more recent than that?
A bit of both. So sort of they're still very old, but they happened much, much later than the formation of the moon. And you can see that in that there's fewer craters in these oceans than there are in kind of the general bright moon surface.
So these big features haven't been all messed up by lots of smaller impacts yet. So it can't have been too long ago. Okay, so number 9.
So this is interesting and not something we fully understand yet. But this is probably the fault of the Earth. Mm-hmm. The moon has non-uniform density.
Okay.
So what that means is, so the Earth, right, if you go right to the middle of the Earth and have a ruler that goes out to the surface, at each concentric ring that you step out towards the surface, you basically have uniform density around that ring. That
sort of spherical ball, that spherical shell inside the Earth, it would be pretty much uniform all the way around that.
Yeah, we're basically onion shaped, right? Lots of layers.
Yeah, good description. So each layer of the onion is the same all the way around, pretty much. But the moon's not like that.
The moon's not like that. It has these really non-uniform clumps where it's overdense. And these are particularly prevalent on the side of the moon that faces the Earth.
Oh, why would that be?
It's probably something to do with the gravitational interactions between the moon and the Earth. Maybe there were large chunks of the moon that got liquefied and redistributed themselves. But we're not most of it's very subsurface, so it's really deep inside the moon.
Right. Could it have something to do with the fact that because the moon's so much smaller that it cooled faster and there wasn't time for it to sort of slosh around and distribute everything around?
Yeah, maybe. I mean, the impact of the Earth's gravity on the moon is huge, right?
Yeah.
We're 6 times bigger than the moon. So
when you think about how much impact the moon has on the Earth, on our both liquid and solid tides, that the impact must be so much greater the other way around, that pulling around entire parts of the structure of the moon isn't so unthinkable.
Yeah, so that's really interesting, these mass concentrations. And number 10, which is actually slightly different in that it doesn't really involve the moon and the Earth at all, but the moon itself provides a fantastic record of the sun's history.
How so?
So it preserves the radiation history of the sun. So periods where the sun became quite a bit more violent and had higher incidence of UV radiation, this is captured in the material that's on the surface of the moon. So different parts, different rocks, if you like, on the moon that are different ages will show different radiation effects from the sun.
Wow. So the moon's a little bit like a sort of astronomical equivalent of an ice core. You know, you drill down into the ice in Antarctica and you can see all the layers that the ice has been laid down. You can see what the atmosphere was like at that time. And you've got a good climate history down through the ice core. This is kind of similar, that the rocks of different ages on the surface of the moon are carrying this history of what their atmosphere was like, which was basically the radiation coming from the sun. That's cool.
Yeah, it's really nice. Yeah. So I mean, all those things together, I mean, they may sound kind of, some of them might sound quite esoteric science, right? You know, whether the moon has a blobby mass inside of it or not, that doesn't really sound like it's going to be hugely impactful. But we've got to put all this together in terms of not only the history of where the moon came from, how we can understand that, but also the understanding of how our whole solar system came about. Huge impacts for planetary science and evolution. And then we're now using that information to understand how other solar systems, other planets around other stars, I mean, the only local data we have is the around us. So we can ask questions like, well, you know, did that star system over there evolve in the same way? Therefore, are conditions going to be suitable for life on an exoplanet?
You've got to think about it that way, don't you? That on the one hand, like, why bother going and studying the moon? Like, how much can you possibly learn? But it's the only experiment that we can do to actually go and get stuff from a moon around a planet like ours. Going and checking out Mars is the only thing we can do to actually go to a planet like Mars. It's the only one we've got. That's the only experiment we can do. And so that's the only way that we can get that information that will inform our understanding of our planet and of the solar system, but of planets and solar systems generally. It's all we've got. In which case, yeah, we've got to go and study the moon some more.
So I think the overall scientific value of those missions is huge.
Yeah.
Huge. And we're still using that very early data to in the exoplanet era that we're in now to understand these other worlds.
Now, you could, if one were being sort of devil's advocate on all of this, you could say, all right, but it is an extraordinary amount of money and effort and time put into what are still reasonably esoteric questions about the origins of planets and solar systems and so on. Like, you care about that. You're an astronomer. You're a space nut. You're a, space flight aficionado. You care about that. But why does the rest of humanity care about that? It's an enormous investment to go to the moon, to collect stuff and bring it back again. And you can kind of understand the sort of criticisms that come up about NASA and space flight generally, space exploration generally, which is, why are we spending this money doing these things when there's so much to be done down here on Earth? And I think it is an important question, given the anniversary, the 50th anniversary of stepping foot on the moon, which was a very expensive thing to do. It was a very expensive footprint. And then the gearing up for this next era of space exploration. It's worth considering. So, I don't know, Emily, what do you reckon?
Well, I think that the way that science and culture have interacted since the moon landings has completely changed. It's changed our lives forever. Because if you think about what science was like in the 60s, of course, scientific endeavor was around. It was great people doing great things. But the moon landing was the first huge investment of money on this scale, right? This is big science. This seems like everyday stuff to us now, right? We invest billions and billions of pounds and dollars into big science today. But I think the Apollo missions were probably the very first time that we'd actually done that.
I mean, the only other one that I can think of that was earlier, and there were probably others, please feel free to contact us and let us know. The only one I can think of immediately is the Manhattan Project. And, okay, that's a whole other moral and ethical minefield. But that was a huge bunch of people getting together, spending an enormous amount of money to do something technological, which, did have a lot of spin-offs from it, but it was also about something not nearly as inspiring, which was creating bombs to blow up a lot of people. So let's park that one for another discussion another time. I think you're right. And the impetus behind this huge goal of getting to the moon and stepping on it accelerated a huge amount of industry and effort and discovery in order to make it possible. What's interesting is then what happened, what came out of that. It changed the way that we operate as a society from a science and technological point of view. But it also gave a lot back.
Definitely. And I think you were talking about today the return on investment that's been estimated for the Apollo missions.
Yeah, I tried to find some concrete figures on this, and I'll keep looking. If I do dig up, whatever I find, I'll put in the show notes. But you do see numbers thrown around of something like a 10-to-1 return on investment, which means, putting a foot on the moon was very, very expensive. But for every dollar that was put into space exploration, $10 came back long term in terms of the technological advances that were used in other areas, in terms of the increases or the increasing ability to engineer systems, in terms of the computational advances that we made and the mathematical advances that we made. Just the sheer return of investment on the science and technology, and that's actual material investment into the world's economy, is huge. It's an investment. It worked. It didn't cost money. It made money, which sounds like a strange argument to make. But you see that occurring over and over again in science and technology. Another really good example, which I think we mentioned earlier, is the Human Genome Project, where, you know, you're mapping out the human genome. It took billions of dollars, but the return on that from medical science and technology, as well as impact on other fields that have got nothing to do with the human genome, it's just using the ideas, is enormous. And so you can't downplay the benefits to society at large from these what seem like esoteric projects, because they're an accelerator to our ability to do stuff at all. It's big stuff.
It is. And I think what's maybe undervalued sometimes is the way that people reacted to this science. So you mentioned like the Manhattan Project was similar in some ways in the terms of that. We put a huge amount of money into this thing. We got a great technological development, but it was a little bit, not
the
sure.
ethics of was it worth it? It's a tough one.
The Apollo program, putting people on the moon, is completely different because the public were inspired. They got behind this idea. Science became part of everyday conversations that people were having. And that reaction from the public was really, really important because it told us that science is good. Science can do good things and it's worth investing in. If you hadn't had that public reaction, if people had been like, well, yeah, whatever. Then a huge amount of stuff would never have followed on from that because ultimately this is being done with the money from taxpayers.
Yeah.
Right?
Yeah.
This is where NASA comes from. This is where most science money comes from. It's everybody in the world
money,
funds
folks.
it. Yeah,
Yeah.
Exactly. And to have the public turn around and say, yeah, that's cool. We like this. It's okay to do science for curiosity. It's okay to do science for courageously, to be bold and do big projects.
Yeah. And then with the other side of that coin being, and by the way, that return on investment across all of science and technology, which will influence all aspects of society, from medicine through to engineering, through to like any field you can name, is enormous, absolutely enormous. So that's icing on an already attractive societal cake there.
Yeah.
But it's,
But then you ask, what if the Human Genome Project happened? What if CERN happened if the reaction had not been so positive, or even if it had been unsuccessful?
Yeah, it's an interesting question, and I think it's really worth considering the value of human exploration, human curiosity, human endeavor in just trying to explore and understand the world for its own sake, without any specific criteria around that. We just want to go and we want to understand and we want to know, is worthwhile in itself, with the understanding that it always has a return. It doesn't mean you don't treat that carefully. It's important to have all of those moral and ethical questions around it, but just know that human trait of exploration and desire to know is itself inherently worthwhile in our species.
And I would say it's probably brought us all closer as well. So when we saw those images from the early Apollo flights as well as Apollo 11 of the Earth, fitting the whole planet into a single camera image.
Yeah, and a really fuzzy one at that.
Yeah.
Really bad. Like you look at that original footage and that's not good television, but it was. I mean, everyone who could was watching that. Yeah.
You took a photo of every human being, every human who has ever existed on Earth is in that photograph, apart from three who were
apart from the three who were there behind the camera, as it were.
Amazing. And I think that sank in, and NASA knew a little bit about the human impact of this. I mean, then they designed the logo, for example. They designed it intentionally with an olive branch, right? This was not, it was hugely politically charged, and there was that context. But in some ways, they were also making this kind of peace offering about it as well, and saying, yes, it is America. Yes, this is what we've done. We are amazing. But on the other hand, actually, this is humanity.
Yeah, we understand the gravity of what we're doing, pun intended. This is species changing stuff that we're doing here, and we need to treat that with care.
Yeah, and from that point, really only these big scientific endeavors were only possible with international collaboration. Yeah. So post the ending of the Cold War and so on, then, scientific unity across the globe. I mean, I look at where my colleagues come from. They're hugely international. They come from every continent. I work with people from hundreds of countries, and that's normal now.
And the next phase of space exploration, will have inherently built into it international collaboration, because it's the only way. I don't think it would be possible for any individual state to be able to do the kind of ambitious work required to get us back to the moon and stay there and to move beyond that. It's got to be international. And that in itself that's a pretty inspiring thing, given the state of the world at the moment, which can seem a bit gloomy at times. Is okay, but there's hope. There's good stuff coming.
I mean, there's a real opportunity for scientists to build those cultural bridges that, in other ways that we're trying to put up walls with each other. But the scientists are saying, well, actually, no, we can't do this without collaboration and working together.
There you go, everybody. Look to the scientists. So, on that topic then of moving out, going back to the moon, we've established, I think, beyond any shadow of a doubt, that going to the moon was a good thing. And now seems like everyone's gearing up to go back. So what is coming up? What is next?
Well, I think we need to think about some questions that I think they're quite interesting questions now. Let's say, okay, we landed people on the moon in 1969. What would be the next kind of follow-on from that? Putting people on Mars, maybe, right?
Yeah, that's a big step. That's hard.
It's a huge, I mean, the orders of magnitude of difficulty here.
Don't underestimate how hard that is.
Yeah. But my question that I sometimes think about is, would putting people on Mars have the same kind of impact as putting people on the moon did in the 60s?
When that first person, assuming it happens, when that first person steps out of the lander onto the soil of Mars, will everyone be gathered around their devices? There won't be televisions, will it? We'll be watching on phones and watches, and probably glasses, our smart glasses at that point, our head up, or the contact lenses with the stuff built into it. But will everyone be watching that, or will it be a little bit sort of, whatever? Yeah,
will it have the same kind of momentous impact? I mean, of course, it's going to be a big deal.
It'll be huge. I kind of feel like it will. I don't know. I'm going to go down on the side of, I think it'll have a really big impact. And I will add to that, I think it's going to depend a little bit on who it is. I think that if there's a clear, this is an international effort and we're sending humanity to Mars, as opposed to it's an American or it's someone from China or whatever it is. If it's clearly, this is humankind going to Mars, I think that could capture everyone. But you don't look so convinced.
No, I'm not so convinced. I mean, I don't want to downplay how amazing that would be, but I don't know if it would be on the level of moon landing.
Yeah, it's hard to gauge that. Yeah. It's hard to gauge that.
And one of the reasons why I sort of wonder about that is this trend that we have, particularly in the last sort of 5 to 10 years, of the anthropomorphification. I can't even say the word now. Anthropomorphication. When we anthropomorphize.
Let's work on this word. Anthropomorphize.
When we make robots.
Yeah.
Have their own personalities and human traits.
Please don't write to us and tell us how to pronounce that word. We know how to pronounce the word. We're just not doing it.
Yeah. So let's think of like Curiosity, for example. Right. Curiosity is Mars's kind of premier rover explorer. Or, when we had Opportunity.
Yeah.
And Opportunity died, and how much
people got really upset.
Human emotion there was.
I got upset,
and
it's because it's not a machine. It's a droid. It's like watching R2-D2 or C-3PO die. Like, that's tragic.
But these are deliberate ways that we've made human interaction with these robots, because
I see what you mean.
They have their Twitter accounts. They have their.
So you're kind of saying that putting a human on Mars is not redundant, but it's not like we haven't already been there.
We've already had an emotional investment in things that are on Mars.
Maybe you're right. Maybe the humans going there is just the next bit. And it's like, oh, yeah, cool. Humans on Mars. Okay. Are they going to go and find the robot?
Yeah.
Maybe dust it off, see if we get it going.
Sing happy birthday to...
Hey, they got Opportunity going again. Yay, Opportunity. Sorry, there's a human being on Mars. Yeah. It doesn't matter. Opportunity's working again. Fantastic. I hadn't thought about this. An interesting idea. would we end up caring more about the robots than the people?
Yeah. It's just very interesting.
Yeah.
Yeah, so I don't know. But, I mean, it's always worth... I mean, it is something we are working towards.
Yeah.
I mean, let's be honest.
Yeah.
The scientific outcomes of those are maybe not quite as significant as they would have been for the moon landing. But that's because you get the biggest revolution in science from just the first things, right?
Yes.
Right.
Yeah.
So we've already had the first things on Mars.
And arguably, I mean, getting back to your previous point, sending rovers and satellites and landers is a much more efficient way of getting the science, getting the data, getting the samples than sending human beings, which is really hard and expensive. And they're lumps of meat that you've got to keep alive. That's much harder than keeping a rover going. And if the rover dies, it's easier to send another one up to replace it with better instruments. The human beings are the hard part. Why would you do that if you had a choice?
Yeah.
Maybe you're right.
Yeah, it's interesting. I mean, there will be some types of science that we can only do with humans. I mean, despite all the things that get splashed across the press, we're not going to be replaced by robots.
No.
We think and act in different ways, not always useful ones, but we have our own wiring that you can't replicate in an artificial intelligence system. So there is an element of there will always be human input into science because it needs that creativity, that level of thinking.
It does take on this interesting aspect of what is the role of the humans. With the landing on the moon, the people were the thing. We're sending people to the moon, and that's the whole point. Going to Mars, well, we've got plenty of things that can do all the science and a lot of the exploration for us. So the point of sending people to Mars would be to send people to Mars. And that's a very different proposition. We're no longer central to the entire Mars mission. We're now just a part of it. And yeah, that's interesting.
However, there are some things to look forward to if you can't wait for the human exploration of Mars.
Okay, what have we got to look forward to? What's coming up?
So, well, this year, I mean, this is a big year for the moon. We've already had a few landers on the moon, a few attempts. Not all of them successful.
But you got to crash a few landers in order to get on the moon or something. Whatever the phrase is.
Yeah, that's the new phrase.
Got to break some eggs to make an omelette. You got to crash a lander to get to the moon.
Yeah. So in quarter three this year, so in the next few months, hopefully we're going to see India has a lovely mission. ISRO has a lander and a rover that are going to be appearing on the surface of the moon. The USA has a private company called Moon Express,
right?
Which is happening sometime in this.
I don't think I've heard of them. You always hear about the SpaceX and the what's the Amazon one, Mr. Amazon. He's got Blue Origin or Blue?
Yeah, that one.
Blue, whoever they are.
Yep.
Those guys. You hear about them, and Virgin trying to get tourists into space, but I hadn't heard of this one.
Specifically for the moon. So
right.
it's a private lander, but it's going to carry an international science instrument called the International Lunar Observatory.
Cool.
So that's quite a cool
Yeah.
one to look out for. That's also that's going to be in quarter four, so towards the end of this year. China have another one going up, so they've got a couple of really successful missions to the moon now, which is really great.
Yeah, they sent one to the poles, didn't they?
Yeah. But no, they have a rover. Already, and so there's going to be a sample return mission, and that's hopefully going to land in December. So very, very exciting.
It's all happening this year.
Yeah, first sample return for 50 years, right? Well, nearly 50 years.
Because the Israeli space organization sent one up not that long ago, which crashed, unfortunately. But again, you've got to try, and they will be back.
Yeah, they've got another one in development, so that's going to be a couple of years. But yeah, it's fantastic. I mean, you think this is a really mixed, bag of companies and countries involved in this. A big one that you might want to look out for is a NASA, ESA, and other international partners collaboration, which is going to happen in 2020. Is they're going to start looking at the first test flights for the Orion missions.
Yeah.
So these are kind of the next step for human spaceflight for NASA. But they're also collaborating with others so that they can put up a whole lot of CubeSats around the moon, which is really, really cool.
CubeSats they're really small, aren't they?
10-centimeter boxes, basically.
Tiny little boxes. And you can take up a whole bunch of them at once, and each one can sort of contain a little experiment or a little device. And they're not particularly expensive because you
No.
can send up a bunch of them at once.
Yeah, the International Space Station has a little purpose-built CubeSat launcher. So it's a little like firing one that just fires them out. Boom, 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 boom. It's really cute.
Very cool.
But yeah, so they want to do some 15 or so CubeSats to go with that one. And then if we're talking about crewed flights, I mean, this is not hugely far away. We're talking about maybe 2022 for a crewed Orion spacecraft to be going on an orbit around the moon, and 2023 for perhaps a private company to be doing the same thing. So SpaceX has their hashtag Dear Moon project. And this is the lunar tourism. I mean, so maybe a year after the astronauts go around, then we'll have some tourists.
That's nuts, isn't it? I mean, very rich tourists.
Oh, yes.
You know, this is not you and me.
No, this is not going to be Ryanair flying to,
Not
some
unless
lovely...
not unless we get some big sponsors for Syzygy anytime soon. I don't think we're going to be going.
No, I don't think so.
But tourists nonetheless. I mean, the only people who have been into space so far have been people who are really trained. You know, the people who've done...
Yeah, there's been a few sort of space tourists, but that's
Yeah.
kind of playing with the definition of what space is.
Yeah.
So there's no tourist been to the International Space Station.
Certainly not
for
to the
example.
moon. It's-
No, yeah. So, this is an exciting time. The anniversary will be marked with a respectful look at the past and where we've come from. But it's also such a nicely timed anniversary to be looking to the future and getting excited about the next 50 years of the moons.
It does kind of make you wonder about that timing. That is, we talked about how inspiring it was at the time. Is there any influence of the fact that we're coming up to this 50th anniversary that has put a bit of a fire underneath people to go, you know what, let's do this, let's go back? I wonder how much of an influence that's had.
I think it will. I think if we look back, and I mean, it's cheesy, but if we say something like, the whole process has been this giant leap for science and scientific endeavor, just trying to imagine what that would be like in another 50 years blows my mind. It makes me very, very excited. And I hope it makes a lot of young people very, very excited too, because we're going to need them on board for the next 50 years.
Well, that brings us to the end of this moon landing spectacular episode of the Syzygy podcast. Look, if we're still going in another 50 years, we might be able to answer some of those questions, Emily, as to what it's like 100 years into stepping foot onto the moon. By that point, we might be broadcasting from Mars. Who knows? That could be kind of fun. Then again, we might be brains in jars at that point. So, so much to look forward to. But we're going to have to find our way out of this episode. So, look, if you have been listening to this podcast and you're sitting there going, yeah, look, nice hour or so of chat, guys, but here's all the things that you just got wrong, or here are my feelings about space exploration, or where do I sign up to be on that next mission to Mars? Or even, I've got a couple of spare billion, I want to send Chris and Emily to the moon as tourists. Look, how can they get in touch with us, Emily? It's really important.
So to get in touch with us, you can tweet us. We are at SyzygyPod, SYZYGYPOD.
That's correct.
And I think actually we're SyzygyPod all over the place.
Pretty much anywhere out on the social networks. If you go and search for SyzygyPod, then you can probably find us. But you can also just go to syzygy.fm. That's our lovely website where you can find all of the past episodes and download, see all of the show notes for all of those episodes and see what we've been nattering on about for the best part of 40 episodes now. So go and check us out there, and there is a contact form there that you can get in touch with us too.
Yep,
Yeah. So listen, if you want to support the show, just give us a review on your podcast catcher of choice. Go and find us on Apple Podcasts or Spotify or whatever it is, and just leave a review. Give us some stars, 5 ideally. That'd be really nice. It helps us to float up through the noise and helps people discover us all over the world. But otherwise, we'll be back again in, a week or so. That tends to be our release schedule, roughly every week, with some more astronomical goodness of some kind. So until then, have a good week. Catch you in a week's time.
See you later.
Bye.
100 feet, 3.5 down, 9 forward, 5%. 185. 75 feet. Car's looking good, down a half. 6 forward. 60 seconds. Lights on. Down 2.5. Forward. Forward. That's 40 feet down 2.5. Picking up some dust. 30 feet, 2.5 down. Straight shadow. 4 forward. 4 forward. Drift into the right a little. 20. Down 1/2. 30 seconds. Forward. Just. Okay. Contact light. Okay, engine stop. ACA at a descent. Mode control both auto, descent engine command override off. Engine arm off. 413 is in. We copy you down, Eagle. Listen, Tranquility Base here. The Eagle has landed. Roger, Tranquility. We copy you on the ground. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.